Welcome to the Mechatronics Revolution Fundamentals and Core Concepts. In this lesson, we'll talk about mechatronics as the interface between actuators, sensors, and computers. I'm Jonathan Rogers. I'm a professor here at Georgia Tech, and I'll be your instructor and guide as we explore the fantastic and interesting and fun field of mechatronics together. In this first lesson, we'll list and describe the core subject matter of mechatronics itself. We'll identify the key areas of knowledge and expertise that we'll need to build mechatronic systems. And finally, we'll look at the basic components that are common to all different types of mechatronic devices. Now you see here before me a couple of mechatronic devices. They look like small robots. And we'll go ahead and show you how they work. This is a simple robot arm that picks up a ball, twirls it around. And this is what we call a hexapod robot. Not all that useful for anything besides entertainment. But one of the things you'll notice about these robots is they have a few things in common. They have actuators in the form of servos in the case of these two robots. They have sensors that help detect the positions of the legs. They also, importantly, have computers. And these computers are special types of computers called microcontrollers that serve to detect what the sensor is trying to tell it and then give commands to the actuators to do what the device needs. Now, every mechatronic device is similar in terms of the different components that are used to build it. So whether it's a dishwasher, a robot arm, a Segway, all kinds of mechatronic devices, they're all made up of the same collection of components. We have, number one, sensors, actuators, electronics, software, and embedded processors. All of these things come together to build the fully integrated mechatronic device. In fact, what makes mechatronic devices different are just the types of sensors or actuators or software or embedded processors that they contain. And this course is focused around looking at each of these different components, how you could select them, how you build them, how you integrate them to create a mechatronic device that works in a particular way. Here's a couple of example mechatronic devices: a hoverboard, a drone, a dishwasher, an electric scooter. All of these mechatronic devices contain the components that we just talked about. They contain particular sensors, actuators, onboard computing, electronics, and software that make them function in a particular desired way. So what is mechatronics? Well, in simple terms, mechatronics is the intersection between sensors, actuators, microprocessors, electronics, software, and sometimes real-time control. So there's certain hardware elements of mechatronics, and then there are certain software elements. So when we study the area of mechatronics, we have to be comfortable both with the hardware side of mechatronics and with the programming, the software side. We'll study both of those things together in this course. Here's a rigorous definition of mechatronics. Mechatronics is the synergistic integration of mechanical engineering, electronics, and control theory in the design and implementation of machines. Now, mechatronics is unique in that it balances both theoretical analysis and hardware implementation. We have to take those two components and perform them together whenever we're designing a system. We'll have to be able to write down equations of motion for things like Newtonian mechanics. We'll have to be able to analyze circuits. But then we'll also have to be able to implement motors and motor controllers and software and electronics, design, etc., every time we actually want to build a real system. So let's talk about what we'll learn in this class. First, we'll learn the theory and the implementation behind microprocessor control and mechanical systems. We'll emphasize an understanding of both electronics and software fundamentals. And finally, the tools and the techniques in this course that we'll learn are going to be portable across different microcontrollers, different motors, different servos, different sensors. We are going to learn a portable tool set so that you can buy different components from different manufacturers and understand how to use them. So what we will need for you as a student to bring into this course is, number one, you'll need to be familiar with basic circuit elements and electronics. You'll also need familiarity with basic electrical concepts, things like voltage, current, power. You'll need to know what those terms mean. And finally, you should be familiar with a little bit of programming, maybe in MATLAB, maybe in Python, C or C++. Some entry-level programming is required because we'll do quite a bit of programming as we go throughout this course. This course is heavily lab-based. You only learn the subject of mechatronics by building mechatronic devices yourself. So the assignments for this class will be largely lab-based. The first lab will design and build a DC motor driver circuit. Then we'll learn how to use a programming environment in Lab 2 and a little bit of C programming. Lab 3 will implement general purpose input and output and interrupt-driven programming on a microcontroller. Lab 4 will involve speed control for a DC motor. Lab 5 will involve serial communication. And then in Lab 6, we'll bring it all together in building an obstacle avoidance robot. To summarize what we've talked about in this lesson, mechatronics is a field of engineering that encompasses the integration of sensors, actuators, and computers. Mechatronic devices are all around us in everyday life, everything from a thermostat to a dishwasher to a refrigerator to a hoverboard. Through hands-on learning, this course is going to provide you with a rigorous engineering foundation in the fundamentals of mechatronics so you can go out and build really cool things.